Welcome. So now we're going to learn about the midsegment of a triangle. And so where median goes from the midpoint to the opposite vertex, midsegment goes from midpoint to midpoint. So a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So if D and E are midpoints, that means that D is going to divide that segment AB into two equal parts. And it means that AD is going to be congruent to DB. And that's because D is a midpoint. And likewise, BE is going to be congruent to EC. And that's because E is a midpoint. And so if we have a segment and it goes from midpoint to midpoint, then it's called a midsegment. Okay? So we're going to learn about this midsegment. It has some special properties that makes solving angles and solving segments a lot easier. All right, so this is the first page in your notes. And it already has the definition in your notes. So a midsegment is a segment that connects the midpoints of two sides of a triangle. All right, so we're going to learn a little bit about it on a coordinate plane because, well, it's easier to see some of its properties at first. Let me see if I can move it up just a little bit. Looks like the bottom's almost off the screen. All right, so first thing we're going to do is we're going to find some slopes and some midpoints. Right, it's really easy to find midpoints. Handy dandy little formula. Let's use this side over here. All right, so we're working with triangle EFG. Let's label the points. So unfortunately I have the notes in front of me because it looks so much nicer in your notes than it is up there. So E is at, let's see, 1, 2, 3, 4. Let's do F first because that's the first one I see. F is at, looks like 1, 2, 3, oops, 2. looks like at 2. Sorry, I forgot to, from my angle, I couldn't see that that was the y-axis. So 2 on the x-axis, and was that 4 on the y? No, 3 on the y. So that's the point 2, 3. Right, and then G, well, the y-coordinate's a horizontal line, so the y-coordinate's still 3, but how about the x-coordinate? Right, so let's see. I'm trying to grab something. All right, so F is at, or E is at 2. No, that's an F. F is at 2. So we got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looks like it's at 14. Is that what it looks like to you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think that's 14. All right, so now let's find E. All right, so F is at 2. How far do I have to get to E? Looks like 3, 4, 5, 6. Well, at least that's what it's going to be now. I think that is 6. And what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be 6, 12. That's what we're going to call it. All right, so we want to find the midpoint of EF. To find a midpoint, I want you to write this in your notes. This is the formula. So to find the midpoint, and so I'll put MID for midpoint. That's just equal to, right? So it's just really just an average. You have to take the average, and it's a point. So you have to take the average of the x-coordinates and divide. So to take the average, you got to add them up and divide by 2, and then the average of the y-coordinates. I don't want that to go actually over the definition, so I suppose we'll just put it over here. There we go. And to do the same thing for the y coordinates. So y1 plus y2 divided by 2. So add the x coordinates divided by 2, add the y coordinates divided by 2. All right, so let's do that. All right, so we want the midpoint of EF. And I'll just label these are midpoints. All right, so we're going to add the x coordinates. So I'll just call this midpoint 1. All right, and that's going to be 2 plus 6 divided by 2. It's a point, so I need parentheses. And then 3 plus 12 divided by 2. And I'm wondering if 12 is the right one because I'm going to end up with a fraction. I didn't think it was a fraction. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, it's 13. Sorry, 6, 13. And so they were 10 away, and I think I looked at the x coordinate, and I added 2 and made it 12 instead of 3 and made it 13. There we go. All right, so 2 plus 6, that's 8. So you've got 8 divided by 2 and 16 divided by 2, and that's going to simplify very nicely. That's just going to be the point 4, 8. All right, so let's graph that. All right, and we'll label that M1. All right, so 2, 3, 4. Oh, it's really hard for me to count. 1, I'm at 3, 4, 5, 6, 7, 8. Right here. And it needs to be on the side, right, because it's the midpoint of that particular segment. All right, so this is going to be M1. All right, let's do the same thing, but find the midpoint for another side. The midpoint of EG. All right, so here's our second midpoint. So we're going to add the x coordinates. That would be 6 plus 14 divided by 2, and 13 plus 3 divided by 2. And that's going to be 20 divided by 2 and 16 divided by, oops, there we go. 2 started to come out funky. All right, and so that's just going to be the point 10, 8. Let's label that one. All right, so here's 14. I'll count backwards. 13, 12, 11, 10. And I'm at 3, so 4, 5, 6, 7, 8. Right here. All right, and that is M2. And let's find M3, midpoint 3. Oh, and over here, where it says midpoint EF and midpoint FG, let's add that. So make sure you have the work so you know how to do it, where these numbers came from. But let's also write it over here. So 4, 8, 10, 8. And then our last one, the midpoint of line segment FG is going to be 2 plus 14 divided by 2, and 3 plus 3 divided by 2. Right, so that's going to be 2 plus 14, 16 divided by 2, and 6 divided by 2, which would be 8, 3. So let's write 8 to 3 over here, and let's find 8, 3. So here's 2, and I'm trying to see these 3, 4, 5, 6, 7, 8. And we'll label that M3. We can even write the coordinates underneath it, but it's not important either way. All right, so we have found our 3 midpoints. All right, now let's find all of our slopes. All right, so we're going to find the slope of EF, and we're going to find the mid-segment slope. Well, to find the mid-segment slope, we better connect the points so we have a mid-segment. All right, so mid-segment goes from midpoint to midpoint, and you know, I'm going to use a graphing tool because that is a horribly unstraight line. All right, so it's not in the right spot, but at least it's straight. I'll fix it. And then we got to connect these 2 midpoints, and we got to connect these 2 midpoints. All right, so what we've just graphed, these are mid-segments. And if I could only move it down. No, I don't want to copy it. I don't want to clone it. I just want to move it where it belongs. There we go. Because I can see where it's supposed to go. It's supposed to go right on 8 there. All right, so let's find the slope of EF. We'll just, as a little reminder, we'll write the slope formula over here. All right, so to find the slope, right, it's just the difference in the y coordinates divided by the difference in the x coordinates, or change in y divided by change in x. All right, so let's find the slope of EF. All right, so we're going to need to use points E and F. All right, so subtract the y coordinates, 13 minus 3, and it doesn't matter who's 0.1 and who's 0.2. I just have to be consistent. So I started with 13, now I need to start with 6. So 6 minus 2. And that's going to give us 10 divided by 4, which reduces to 5 halves. All right, so we'll put that over here. So you should have it on the side, because I know you guys at least as much space as I've got. And then we'll put it in our graph. Now, the mid-segment slope is the slope of the segment that's opposite to it. All right, so in other words, it's not one of the segments that intersects it. All right, so I'm going to color code this. Here we have EF. Here's the mid-segment that goes with EF. In other words, it's not going to intersect EF. Let's find that slope. And we should probably, I'm going to write the coordinates underneath it just because I think it's a little easier when I'm looking. So this is 8, 3, and this is 10, 8. Really didn't matter until we started finding slope, and I'm like, maybe it's a little easier for me at least. All right, so we'll find the slope now of, and we can call that, so that's going to be called M2, M3. It's connecting those two midpoints. All right, so we have 8 minus 3 divided by 10 minus 8, and that's going to be 5 divided by 2, 5 halves. Look at that. They happen to be the same. Since they were the same, let's put a parallel line marking on those. All right, and now let's find the slope of FG. All right, so I'm just going to do that. All right, so for FG, where are you? FG, there you are. There you are. The one on the bottom there. So it's going to be 3 minus 3 and 2 minus 14. And since it's 3 minus 3, which is 0, really doesn't matter what's in the denominator, because that's going to be 0. That's a 12, by the way. It looks almost like a 72. So that's a slope of 0. Its mid-segment is the one that does not intersect it. It's opposite to it, so it's right over there. All right, let's find that slope. All right, so we've got 8 minus 8 and 10 minus 4, and that's 0 as well. So since they were the same, let's mark that they're parallel. So I'm going to use 2 markings now, not to be confused with the 2 lines with 1 marking. And now let's find the slope of the last pair. All right, so obviously the only 2 that are left, this one and this one. Notice they don't intersect one another, at least not in that triangle. Let's see what their slopes are. All right, so slope of EG is going to be 13 minus 3 divided by 6 minus 14, which was 10 divided by negative 8, and that's going to reduce to negative 5/4. Let's do the same thing, only now it's the mid-segment. All right, so that's going to be 8 minus 3 divided by 4 minus 8, and that is 5 divided by negative 4, which is also negative 5/4. So let's put that in our little chart there. And since they have the same slope, let's put 3 parallel markings on those 2 segments because their slope was the same. All right, so let's learn a little bit about a mid-segment. So triangle EFG is graphed on a coordinate grid. Find the midpoint of each side and then graph all three midsegments of triangle EFG. And we did that. Right? We found the midpoints by using the midpoint formula for each side. Right? And then we connected the midpoints. Then we wanted to find the slope of each side and the corresponding midsegment. Well, we did that too. Calculate the length of each side of the triangle and the corresponding midpoint by using the distance formula. We haven't done that yet. Right? So hopefully you can see a couple things so far, or at least one thing, and that is that the midsegment is parallel to the side opposite it. Let's see if there's any relationship between the length of a midsegment. So let's find the length of segment EF. Right? So we're going to use the distance formula as a little reminder. I will squeeze the distance formula in right here. Here's our distance formula. Because I'm not going to write it every single time. I'm just going to fill in. Right? So it's the difference in the x-coordinates squared and the difference between the y-coordinates squared. All right, so we want the length of EF. So that's going to be the square root of 13, I used to doing the slope. 2 minus 6 squared plus 3 minus 13 squared. Okay, now I'm going to squeeze that in here. All right, so that's going to be negative 4 squared. And you, by the way, you do the same. We need parentheses around that because that negative is going to be squared. And then plus negative 10 squared. And now, where am I writing? There's a little bit more space. I'll just squeeze it in right below here. There's room. All right, so that's going to be, if we make a really not too tall radical, we have 16, and then we have plus 100, and that is the square root of 116. For right now, we're just going to, since we're just comparing it, later on we could simplify the radical if we like, but right now we're just going to leave it like that. All right, so now let's do the same thing, only for the midsegment. All right, so the corresponding midsegment, let's write the name in. So it's M3, M2. It's the one connecting those midpoints. All right, so that's going to be the square root. And we've got, where's my points? 8 minus 10 squared plus 3 minus 8 squared. And my radical is way too short. All right, so that's going to be, I'm going to come down here, equals the square root of negative 2 squared plus negative 5 squared. And that is 4, oops, for some reason I wrote a 5, 4 plus 25, which is square root of 29. Not a very interesting number. And we might want to go back and simplify that radical. Did I make, let me just check that I use the right points and I'm looking at the right thing. So 2 minus 6, yep, and 3 minus 13, good. And 8 minus 10, and then 3 minus 8. Okay, let's continue on. All right, so now let's find the length of segment FG. Well, that one's really easy. We don't really need to use the distance formula for that, right? So it's just the difference between 2 and 14, and that's just 12. The mid-segment that goes with that, actually I'll keep my color coordinating there. Since that side is green, whoops, and there goes my pen. I'll write 12 in green. All right, the mid-segment that goes with it is the one that's connecting M1 and M2. And that is, so again, we've got a horizontal line, so the difference between 4 and 10 is 6. Well, gee, we can see the relationship there, 12 and 6. All right, let's just take a look at EG and the mid-segment opposite that one. All right, so EG is over there. So we have, now we have to use the distance formula again. So that would be the square root of 13 minus 3. Okay. Squared, right, because we're finding the length of EG. And, oops, why did I use the y coordinates first? Sorry about that. 14 minus 6. 14 minus 6 squared plus 3 minus 13. Oops. Having issues here. Every time I put my head up, I forget what I've written. I've written 3 minus 13 squared. There we go. It's really too big. Fortunately, I've got a little bit more space here. I wrote those numbers kind of big. So 14 minus 6, that's going to be 8 squared. And 13 minus 3, that's going to be negative 10 squared. And I'm going to just keep on writing here since I've got some space. That's going to be 64 plus 100, which is a square root of 164. We'll just leave it like that for now. The corresponding mid-segment is the one that's opposite it, so that's from M1 to M3. Let's find its length. All right, so we've got 4 minus 8 squared. I never make these radicals big enough. And 8 minus 3 squared. Okay, and so 4 minus 8, that's going to be a negative 4 squared. And 8 minus 3 is 5. So that's going to be square root of 16 and 25. So that's the square root of 41. And that doesn't look very interesting either. Now 12 and 6, we can see a relationship there, right? Because 12 is twice 6, right? 6 times 2 is 12, or half of 12 is 6. But not so much with the other ones. Maybe, just maybe, we should simplify the radical. Let's do that, right? Maybe we'll see a relationship if we simplify the radical. So I'm going to do that off to the side here because we're almost out of space on this page. All right, so we have the square root of 116. What divides evenly to 116? Well, 2, right? So 2, that would be 5 and 8, right? And, well, that would be 2 and 29, right? So 1, 2 would come out, 1, 2 would go away. So that's 2 square roots of 29. If we can actually see it. Let's see if I can move this over. Oh, I can move that over a little bit. Well, now I think everything broke up, so I can move everything. Now let's see if we see a relationship now. We didn't see it before. It's like, that's not very interesting numbers. We've got 2 square roots of 29. And if you can see that. All right, that's the length of EF. Right, so EF equals, 2 square roots of 29. There we go. And FG, the other one there. Actually, let me write that in blue so you can match them up. So EF is 2 square roots of 29. That actually looks a teeny bit better. And this one here was just the square root of 29. Well, now I see a relationship because the 2 square roots of 29 is twice as big as the square root of 29. How about if we simplify square root of 164? Right? And where are we going to do that? Oh, we're just going to erase this one. That's what we're going to do. Square root of 164, but that's clearly divisible by 4. So 4 would go into that 141, and then 4 is 2 times 2, and 1, 2 comes out, 1, 2 goes away. So that's going to be 2 square roots. I'll put it over here. 2 square roots of 41. And so now this segment here, EG, was 2 square roots of 29. And the other segment that was parallel to it, 2 square roots of 41. And this one here was the square root of 41. Well, I know that 2 square roots of 41 is twice as big as the square root of 41. And I know that 12 is twice as big as 6. I'll write those in 2. This one was 6, and this one is 12. And now I think on our coordinate plane here, you've discovered a relationship between a midsegment and the opposite side. All right, so a midsegment of a triangle is, and let's fill in the blank there, parallel to a side of the triangle, and its length is half the length of that side. And it's always the one that it does not intersect. It obviously can't intersect it because it's parallel to it. Right? And so now using a coordinate plane, you've discovered some relationships about midsegments. Right? There's a relationship between the midsegment and the opposite side. Right? They're all going to be, the midsegment and the opposite side are going to be parallel. And because M1, M2, and M3 were midpoints, this has to be congruent to this. This has to be congruent to this. And this has to be congruent to this. So we got a lot of things that are easy to figure out if we know just a little bit of information. So in the next podcast, I think I'm going to end this one. In the next podcast, let's move off this page and let's learn how to find the solve and find measurements using the midsegment. All right, bye for now.